Welcome back, students, to another edition of BAP, Business Analytics Programming. Today, this video is going over practice set 4. So I have the practice set 4 open, I have my Excel sheet open, and I'm just going to jump right into it. All right, starting with number 1. I'm just going to go ahead and save this too. Perfect. All right, number 1. So here, number 1, we have a series, we have another series B, and then I combine them into a table DF, and then I ask you to do something, give me some solution. All right, so if you guys remember, we talked about this before. You have to, when you're making Pandas data frames explicitly, you have to look at the indexes, right? The indexes, if the indexes are exactly the same, I don't care if it's 2 series you're using or 200 series, all the indexes must be exactly the same. Then the order will be preserved as the way the indexes are presented. If just one thing is off, then it must become alphabetical order. In this case, Series A has peach, orange, melon, cherry, apple. Series B, apple. Okay, right off the bat, the first index, they're not aligning, right? The first indexes are not aligning. Therefore, we're going to go ahead and put this in alphabetical order. We're going to put the indexes in alphabetical order. All right? So what I'll do first is I'll write down the indexes and then I'll fill in the values. So there's going to be a column A, there's going to be a column B. We see that over here in line 3 of the code. And the indexes will be down here. And like I said before, they're not going to be in alphabetical order because they don't align properly. So I'm going to have apple, cherry, M-N-O-P, melon, orange, and peach. All right. And now I just stick the values in. So for Series A, peach is going to have the value 5. Orange is going to have the value 4. Melon will have the value 3. And cherry will have the value 2. And apple will have the value 1. I go to B, do the same thing. Apple is 50. Cherry is 40. Melon is 30. Orange is 20. And peach is 10. So I've constructed a table, and that's how it looks like. Once you have the table, you can now solve for x. X is literally going to be the sum of, go inside out, df, which is this table. iloc, remember iloc is done by positions, not by indexes. So iloc 2 literally means 0, 1, 2. So it's this row. And then I'm selecting the columns 0, 2, which is literally going to be the first column, the second column, but not the third column. We just have 2 columns anyway. So it's just literally selecting these values right here within that row. And I'm summing those 2 values, which is going to be 33. So the answer is 33. Number 2. All right, number 2. I have a series A, apple, cherry, melon, orange, peach. Series B, apple, apple, cherry, cherry, melon, melon, orange, orange, peach. This order is exactly the same, therefore the order will be preserved. It just so happens that the order is written in alphabetical order. All right, so just like before, I'll have an A and a B. The name of the table is now df2. And now I'm going to have the indexes apple, cherry, melon, orange, peach. For A, the values will go literally down 5, 4, 3, 2, 1. And for B, it'll also be 50, 40, 30, 20, and 10. All right. From here, I'm going to go ahead and just do the math it's asking for. So again, here we're using iloc. And the first value I have is 3. So 0, 1, 2, 3. Highlight this. And then I'm selecting, now I'm using the brackets comma system to gather the columns. And again, it's just selecting the 0th and the 1 column. So again, these two values. And I'm summing them up, so my answer will be 22. Oops. Number 3. All right, so number 3, I have a series A, peach, orange, melon, cherry, apple. Series B, peach, peach, orange, orange, melon, melon, cherry, cherry, apple, apple. Excellent. They're in the same order. The order will be preserved. So I will write down the order: peach, orange, melon, cherry, apple. I'm going to put the two columns there, A and B. The name of the table is DF3 now. And I'll stick the values in. 5, 4, 3, 2, 1. Let's cheat here a little bit. 5, 4, 3, 2, 1. And 50, 40, 30, 21. 10. Alrighty. From here, I will now do line 4. So line 4, I'm using iloc again. iloc, I'm selecting 0, 1, 2. It's the second row. And now I'm using the second set of brackets afterwards to select the column. Remember, when you use the second set of brackets, now we can select the column name while using iloc. So that's a little trick. So here now I'm selecting the B column out of that row, which is going to be 30. So the answer is 30, very straight up. Number 4. A has index peach, orange, melon, cherry, apple. Peach, peach, orange, melon. Okay, the second indices are not in the same order. Therefore, this whole thing now will go in alphabetical order. All right, so the indexes will be, first of all, the column names from right here will be A and B. A, B. And it'll be apple. Oh, also notice something. Here, there's only 4 indexes, and here there's 5 indexes. So that's another reason why this is going to go in alphabetical order. The indexes are not of the same size, let alone same positions. So we're going to have apple, cherry, melon, orange, peach. Right, and I'll stick the values in. So peach has the value 5. Orange has the value 4. Melon has the value 3. Cherry has the value 2. And apple's 1. For here, peach is 50. Melon is 30. Cherry is 20. And apple is 10. This one will have the value of NaN. Remember, NaN is basically null in the Pandas table. All right, so now I'm going to do line 4, which is basically saying iloc 3, 0, 1, 2, 3, highlighting this row then. And take the whole row and sum it up. Okay, now the answer here will be 4. Why? Because the sum function we're using is the dot sum. It's the sum that is innately built in to Pandas tables. See, we're calling dot sum on iloc, which is being called from dot df4, which is essentially a data frame, which is a pandas data frame table. So it's the sum function innately built into Numpy and pandas. All right. That sum function ignores the NaNs. That sum function ignores the NaNs. Now, had instead I written this, x equals df4 dot iloc, write that again, sum df4 dot iloc bracket 3, close bracket, what would x be? Here, x would have been NaN. It would be NaN or null. Because the outer sum function, this is the default sum function from Python, right? That, if there's just one NaN, it'll make everything NaN. Whereas the inner sum from Pandas and NumPy, the dot sum, that ignores any NaNs. So just remember that, right? Just remember those two differences. Those are the two differences between the outer sum and the dot sum. So in this case, for number 4, the answer is indeed 4, because we use the Pandas NumPy sum as opposed to the default Python sum function. Okay? So that's a very cute little Python job Q&A question sometimes they give you for beginner programmers. Number 5, given table df below, right here, what is x? Okay, so here I have df, and it's this table right here, 4 columns, those are indices. And now I'm doing a group by. Okay, excellent. So, and it's storing as E. Remember, when you do a group by, E will become a series, right? E will become a series. So I'll present the series being vertical, just like they do in Spider. So here I'm grouping by D, and then I'm selecting all the C values in the subtable of D's, and then I'm summing them up. All right. So let's do this, right? I'm going to do this. I'm going to take the extra step to show you how it's doing the summation, right? Because just out of practice. All right, so if we're grouping by D, remember the steps. Here's a D column. How many unique values there are? 4, 5, 2. So there's a 4 subtable, right? There's a 4 subtable. And the 4 subtable will basically have the values 4, there's only one 4, all right, so it'll be literally 0, 5, 4, 3, 4, okay? There is a, oh, and then we're summing up, we'll do the sum in this section. So we're taking this, we're selecting the C column from here, and we're summing it up. There's only one column here. I mean, there's only one row. So this will literally give us the value 3 back, all right? So for 4, it's going to give us the value 3 back. All right, so let me do now the next value is 5, the 5 subtable. And the 5 subtable has 2 values, a 1 index, the 4 index. All right, so 6, 3, 4, 5. All right, and now we're highlighting the C column again. And now we're applying summation to it. So the answer here is, now this is going to give me the value back, 10. All right, so here I'll just write down 10. It's coming back from the 5 subtable. And now, lastly, it looks like we have the 2 subtable. And again, there's 2 values. It's going to be a 2, 3. I'm just copying the indexes. So then we have the 2, the 3, the 5, the 2, and the 2, 6, 1, 2. Alrighty? Yes. Highlight the C column, sum it up, and I'm going to get the value back 6. All right. So what happens is, now the final step is you bring back the group by values into a series, and this series is literally going to be the series value E, and it's going to have the indexes will be basically the whatever you group by, the group by values were. So in this case, I have the 2, 5, and 4. Now remember, when you're bringing it back, right? When you're bringing it back, the indexes always come back in. If you remember from our from our lab 1, the index, when you do the group by and the values come back, the indexes, whether they're alphanumeric or numeric, they come back in order, ascending order. So in this case, I have the indexes here will be the whatever the unique subtables were created. So I have a 4, 5, and 2. So because these are numbers, I have to put them in numerical order, ascending order. So it's going to be literally 2, 4, and 5. Those are the indexes. And the values will be whatever the sums were ended up being, 3, 10, and 6. Right? So that's what E becomes. E now is a series. Here's the indexes, and here's the values. All right? I should just put the, and let me just move the E actually over here, just so there's no confusion. All right? So these are the indexes, and these are the values. Okay. Now from here, in line 2, I'm creating a new column in df called column E, and it looks like I'm going to be, the value is going to be set by column D mapping to E as a dictionary. You remember that we can convert a series or even a table, a Pandas table, into a dictionary by using the .toDict function. Now what happens is, in here, the E.toDict function, this is E, this is going to convert this series into a dictionary. And it's going to work very simple, where the indexes become the keys and the values are the values. Okay. Here, this obviously a new column is going to be created called E, right? And what I'm going to do is, I'm not going to write down the whole table. Actually, should I write the whole table? Let me write down the whole table just this time. So we have A, B, C, D, and a new table E is going to be created, right? 0, 1, 2, 3, 4. And what I'll do is I won't write the other values, but I'll write the values for E. Just move this over a little smidgen. All right. And so what's going to happen here is, for E, the E value will be whatever is the D value. Let me write down the D values, which are 4, 5, 2, 2, and 5. So basically what's happening, the D values are going to be mapped to this dictionary, the E dictionary, right? And the D values will serve as the keys, and the keys will be sent to the E dictionary, and from the E dictionary, the value will be sent back up all the way to this new column E being created. So let's do this. First value is 4. It's being sent here to this new dictionary. The series being converted to a dictionary. 4 has a value 10. That 10 gets sent to the column E as a new value. 5 has a value 6. 2 has the value 3. 2 has the value 3. 5 has the value 6. All right? And so line 2 basically creates this new column of these values right here. And then finally, for X, the question is literally the table df, the column E, sum it up. All right, so the answer basically becomes, looks like the answer will be 38. 12 plus 16 is 18. 22, for some reason I can't do math in my head anymore. 22, 25, 28. All right, excellent. So looks like the answer is 28. Hold on. What am I doing here? These are wrong over here. Guys, when I copied over the E, I'm sorry, I constructed it incorrectly. Some of you guys are probably shaking your head. 4 had the sum value of 3. So sorry about this. 5 had the value 10. 2 had the value 6. Right? This is how the E series should look. I apologize. Some of you guys are probably already emailing me at this point at the video. So 2, remember, is 6. I was looking up. I was like, what's wrong here? 2 is 6. 5 is 10. And 4 has a value 3. I apologize. All right, now let's delete this and do this again. Okay, let's do this again. 4 has the value 3. 5 has the value 10. 2 has the value 6. 6. And 5 has the value 10. This gives me a value of 12, 15, 35. If I sum this up now, x is now going to be 35. All right? Apologize for that. So the answer is 35. My mistake was here when I copied over the values. I lined up the index correctly, but I copied the values off incorrectly. All right, so that is number 5. Number 6. Okay, so we're doing another group by. This time I'm grouping by A. And this I'll do slightly faster, okay? So I'll start off with the series that's going to be created is going to be E. So I'll just put E over here. And E, I'm grouping by A, so I'll look at A. And I'll just go in order. So I have 1, 2, 3 unique values, and I'll put them in order, because that's how the series is going to come back to me anyway. So we have a 2 subtable, a 5 subtable, and a 6 subtable. Okay? 2 subtable, 5 table, 6 subtable. And what's happening is, for each one of those subtables, the B column is going to be highlighted, and it's going to be summated. All right? So let's look at the 2 subtable over here. So the 2 subtable is literally these 2 right here. That's easy. I'm going to highlight the B column, which is these 2 parts, and I'm going to sum them up for the value of 9. Next is 5. 5 is a little difficult because they're spaced apart. So here's 5. Here's 5. The column B values are 4 and 6, right? And if I sum up the 4 and 6's, right, I get the answer 10. And finally, 6 is going to be easy. It's just one value. Sum that up, it's going to be 3. So I'm left with a series like this. All right, I'm left with a series like that. So from here now, I'm going to go do line 2. And line 2, we're doing the same mapping as we did it before, but now we have a slightly more complex code in here. It looks like we're filtering as we're creating the dictionary. Remember, always go inside out. All right, no matter how crazy or insane the code looks, just go inside out. So what's going to happen here is, here's my E series, okay? Now, my E dictionary, I'll literally call it E dictionary, right? When you do E dot to dictionary, is going to look like this. Well, first of all, I have to filter E by all the values that are greater than 3, all right? So where are all the values greater than 3? This one and this one. Therefore, what's going to happen is that 3 will be dropped because it doesn't meet the criteria. Then that subtable of E will be converted into a dictionary. So this will be the dictionary. So I'll highlight this. Here's my dictionary right there. And I'll literally call it E in parentheses, the actual dictionary, right? So that's one we're going to use. All right. Now I'll go ahead. I'm going to cheat a little bit. Grab this table. Skip that. Oh, I'll keep that. Delete all that. And now it looks like C, the C column, will serve as my keys. So my C values are 3, 4, 5, 1, and 6. 3, 4, 5, 3, 4, 5, 1, 6. Excellent. And so now, all right, I'm going to do my mapping. I can delete this because I don't want to get confused. Right, so here, 3 is sent to here. Don't confuse it for this one. Remember, it's a sub-filtered version. 3 is sent here. There is no 3. This comes back as NaN. It's going to be a no. 4. There is no 4 here. NaN. 5. I have the 5. 10. 1. There is no 1 there. NaN. 6. There is no 6 there. NaN. Only one value gets filled in. Everything else remains null. And from here I do x equals df table, the E column, sum. And as we talked about above, this is going to give us the answer 10 because we're using the sum function that comes built into the Pandas table, as opposed to the outer sum function that is the default sum function from Python, which would give us an NaN. Right? So here the answer is 10. All right, and that is number 6. That is number 6. From here, I'm doing number 7, which should be a review question. So here I gave you guys these review questions just for some of you guys. I saw some of you guys made this mistake. Again, x is going to be an array, NumPy array of floats, meaning decimal places. Y. See the 5 dot over there? That's going to create a NumPy array of floats versus integers. So this is literally going to be 5 dot. I will put that dot there to signify that it's a float. 4 dot, 3 dot, 2 dot. Oh, I'm sorry, I'm doing this wrong. Remember, when you just have one value, it's the default value starting point is going to be 0, and the default stepper is 1. So this is literally going to be actually a 0 dot, 1 dot, 2 dot, 3 dot, and 4 dot. Obviously, that number is, as you guys remember, exclusive. So that's what x is going to be. I apologize. Now, the third value of x is going to be set to 3.5, and it will take the 3.5. Why will it take the 3.5? Because these are all floats. 0, 1, 2. Now turn into 3.5. And now I take the sum of it all, and the answer for y will be, y will end up equaling 1 plus 3 is 4, 4 plus 4 is 8, 8 plus 3.5 is 11.5. All right, that's just a refresher because I saw some of you guys made that mistake on the first midterm. Number 8. All right, so now here in 8 now, notice I create a NumPy array of strictly integers. I can't now, if I were to set a value equal to a decimal place, it's going to drop the decimal place. All right, so here x is 0. Notice I dropped the dots. 1, 2, 3, 4. All right, now look at what's happening. Something very interesting is happening here in line 2. I'm taking the third value, or essentially the fourth value of x, multiplying it by 3.5, and setting that value equal to the third value in x. Let's play this out. Let's do the right side first. So the right side is the fourth value of x is 0, 1, 2, 3, 3. And we're going to multiply that by 3.5. Now remember, this is math we're doing, and we're allowed to do this outside the space of storing values. We're not storing values in anything. We're just simply doing math. So this will equal 3 times 10.5. This will equal 10.5. And the decimal place will be there. All right? Do the math right. 9, 15. Yep, 10.5. From here, guys, from here, the question is, what happens next on the left side? So now x of 2, 0, 1, 2. The 2 over there is now they're saying change that value to 10.5. Well, now we're trying to store a value, a float, in the third position of a integer NumPy array, we can't have that. The decimal will drop. So it'll take the 10, but it will not take the 0.5. It'll take the 10, but it won't take the 0.5. Therefore, x becomes that NumPy array. All right, and the sum of y will now equal 18. 18. All right. So on the right side, the math was fine. We were cool doing the math because we're just doing math, people, on the right side of the equals. But when we wanted to take that float and store it within a position within x, that's where we had the problem, right? So that was a no-no. Decimal got dropped. Decimal got dropped. Number 9. What is z? So here x we have very straightforward. 0, 2, 4, 6, 8. And now y is, okay, now look what's happening here. Here I'm overwriting all of y. So this is going to be allowed. Firstly, in x, I am multiplying, I'm doing vector mathematics. X times 1.5, it's going to bump them all up to floats. So now I'm going to get a temporary array that's going to be literally 0, 3 dot, 4, 6 dot, 9 dot, and 12 dot. Alrighty, and that's a dot there too. And again, I do this for I do these for aesthetic purposes to remind myself that these are floats versus integers. And when you're doing your problems, you should do the same thing so you don't make a mistake on the exam. All right. Now in line 3, now in line, sorry, we're still in line 2. Line 2, I say y will equal that. So this basically now becomes y. All right. Now in line 3, I'm saying z equals y. Remember, this is one of the headaches that Python gives you. When you do z equals y, clean like that, it doesn't make a new z. It simply says, hey, okay, cool. This array y shall now be called z as well. So you have two variable names pointing to the same exact NumPy array. Now I'm going to do line 4. In line 4, we have a single equals there, so I'll do the right side first. So on the right side, I'm selecting the values, the 0th value from y, which is 0, and the 4th value, which is 0, 1, 2, 3, 4, 12. All right? And those two values will be set to the second and 4th value of z, which is essentially y. So let me copy this right here, perfect. And now what I'll do is, step by step, going left to right, I'll overwrite it. So I come here to the second value, 1 here, 1 colon 3, 1 here represents the second value. And this will now become 0. All right. And then the next value is going to be obviously 2, which is the third value, 0, 1, 2. And this will become 12. And the third one, obviously, we ignore it. Remember, Python, we ignore whatever is to the right of the colon. So what happens is x now becomes 0, 0, 12, 9, 12. Right? So what is z? Z becomes 0, 0, 12, 9, 12. Now, that's the answer right there. Number 10. All right, so what's happening number 10? Number 10, I also have the NumPy array, 0, 2, 4, 6, 8. I shall steal this from here. I'm doing the math, y equals x times 1.5, like I did up there for number 9. I shall steal that as well. Z equals y, I'll leave that. That's the same as well. 6, 9, okay, yeah, that's good. And now I have this going on here. All right, so z of 3, let's do the right side. Z of 3, which is what? 0, 1, 2, 3, 9 plus 2.5 gives me 11.5. All right. Now on the left side, I'm saying change the second value of y, again the same thing, or the third value, 0, 1, 2. Let me copy this. Zero, 1, 2. The 6 is going to be changed to that value. Now, because this takes numpys, this takes floats, it will take the number and the decimal. And so this is what z ends up becoming. And there you are. Number 10 is done. $11. All right, so we got a little for loop action here. That should be easy for you guys at this point. 4, 3, 2, 1, 0. I have my x. I have my y. 11, 13, 10, 11, 13, 14, 15, and z is that. And now I have the for loop. All right, so I'm an iterator I that's going to iterate through x. I have 5 values in x. I'm going to have 5 loops. Right. So loop 1, I equals 4. Right, I will equal 4, the first value of x. Now we have this condition here. Is I greater than 2? Yes, 4 is greater than 2. Then append z. We're going to append the value y of I, which is essentially y of 4. What is y of 4 here, guys? 0, 1, 2, 3, 4. 15. Oops, put a parenthesis there. Y of 4, right? Y of 4 is going to be 15. 15 is appended. Go to loop 2. I will now take on the value 3. All right. Come here to the first condition. Is 3 greater than 2? It is. So again, I'm going to execute line 6. Right here. This is true. Z dot append y of I, which becomes, what is y of I? Basically here, what is y of 3? Y of 3 is 0, 1, 2, 3. It's 14. So now I'm going to append 14. Alrighty. Now we go to our third loop. I is now the value 2. And now I come here to the first condition. Is 2 greater than 2? It's not. I'm going to skip this, go straight to the else, and do z dot append I. Z dot append I, that's easy. Just appending 2. Go to the fourth loop. I now has the value 1. Come to this condition. Is 1 greater than 2? It's not. That fails as well. We go to else. Append I, which is 1. And we finally come to the last loop. Loop 5. And I has the value 0. 0 greater than 2? It's not. We come to the else. And now we're just going to append the value 0. Alrighty. So what is z at the end? We're finally done. It is right there. All right, that's number 11. Number 12. Yes, number 12, I have you fix the code. This, you basically just have to double check with your with the code in the lab we went through. So let's look for the errors, right? This is all API stuff. So here I do API turns available, no problem there, no problem here. An import, normalize, no problem. Value counts, not a problem. Not a problem, not a problem, problem. Remember this? Remember through the pain I went through, you guys, to explain to you what happens when you use LOC to do a logical slicing and dicing of a table? What comes back? This becomes a series. And remember how I said we out in Twitter, that Twitter lab, this gives us an error. This gives us an error because it's expecting a number, the WOA ID, but it's a series. So how do we fix this? This will literally be ny underscore trend equal trends dot place ny dot value. So you could do ny values bracket 0 and fix it. Alrighty, easy enough. Number 13. Which pandas function normalizes JSON objects? This probably has to be the easiest question. JSON normalize. Normalizes JSON objects. Number 14. You have an API function that returns a JSON object within a JSON object. All right, one of those nested JSON objects that we get from Twitter. And that is stored, that object is stored, that data, that JSON within a JSON object is stored in a variable called X. All right, so that's the data container that holds that JSON object within a JSON object. The JSON object within a JSON object is actually named screen name. So you have an X variable, and within it you have another JSON object called screen name. Normalize the inner JSON object into a pandas data frame named df. Right, a pandas data frame named df. Let's see if I can do illustration here for you guys. So choose this. So here, let's say this here is X, all right? It's a JSON object. And then within here, there is another JSON object. Let's change the color. Here, called all right, so add text called screen name. Oh, that's hideous. Make this bigger. There you go. There we are. So this is right here. This outer one is X, and then within this JSON object, there's another JSON option called screen name. Question is, how do you normalize that inner JSON object without using multiple lines of code? All right, no problem. And you store that, and you're going to store that in a data frame called df. That was a trick I showed you guys using JSON normalize, using the second parameter. X, comma, we're going to do a comma, and in quotes, we just put the inner JSON object that we're looking for, and we normalize it, just like that. All right, it's just like that. That's how easy it is, guys. And finally, number 15. All right, how many rows of tweets will be in the table df2? Assume unlimited tweets. All right. I created two tables here, df2 and df, mid equals 0. And what I'm doing basically here, I'm iterating, it looks like I'm going to run this loop 20 times. All right, I'm going to run it 20 times. And what happens here is, where do I use df2? Here's where I use df2. So I'm basically, looks like I'm looking at the screen names for Mark Cuban. I'm grabbing his, whatever his tweets. and I'm basically storing them. And when I grab them and normalize them, I normalize them in a table called df, all right? And then it looks like I concatenate df into df2 for every loop. So if this loop runs 20 times, right, and the first time it ran, I got 100 values back, and the other 19 times I got 100 values back, right? And each one of these values are going into the df2 table. First off, let me ask you, if I said what, after the code ran, what would how many rows of tweets would there be in df? That answer would be 100, because the last time the last loop runs, it's literally going to be size 100. But I'm asking for df2, and the first time it runs 20 times. The first time 200, the other 19 times it's going to have 100 tweets, for a total of 200 plus 19 times 100. So it's going to be literally 1900 plus 200, 2100. So the answer comes out, I'm going to have 2100 tweets, right? And basically I have 2100 tweets, and that's my answer. All right, and this is from lab 3 pretty much, where I showed you guys how to extract more data from Twitter using the Twitter APIs and using the whole IDs and the max ID parameter to get more and more data. Okay, so this is how we end up. Had we basically had 200 here the whole time, here and here, then our math would have been easy. It would literally just be 200 times 20. We would have 4,000. But because I changed that to 100, sneaky me, it's literally going to be 1900 plus 200 for the first one, which gives us 2100. So this concludes our practice set 4. All right. Hope if you have any questions, give me some feedback, shoot me some email. We can talk about it. And I will see you guys on the next video or Q&A session. All right. Bye, guys. Have a great day.